Physics, chapter 19, theory video 8. We are going to discuss about thermometers. So a thermometer is any device that can be used to measure the temperature, or take a reading about how much of thermal energy is contained within it. So then what a thermometer does is, it makes use of some physical quantity or physical property of a material that would change with temperature. So now if you take the liquid in glass thermometer, what it does is, the liquid expands when exposed to heat transfer. So that expansivity is what we use. The most familiar is the length of a column of liquid in a tube, which gets longer as the temperature increases because the liquid expands, so that the volume increases. Right? So that is how liquid in glass thermometer works. Then other physical properties that we use, now we have already learned this in O levels. We use the resistance of an electrical resistor or a thermistor. Right? So thermistor. Then we learn about the EMF produced, that is a thermocouple thermometer. Then we also can use the color of an electrically heated wire. Then volume of a fixed mass of gas at constant pressure. So different properties that can be used to measure the temperature are these. In each case, the thermometer must be calibrated. What is to calibrate? Calibrate is to mark from 0 to 10, this is the change that happens. 10 to 20, this is the change that happens. So like that, we calibrate. We fix melting point, then boiling point of water, that is 0 to 100. So we mark these things. And we have a scale between the scales are divided between the two quantities. We have divided it into equal divisions, right? When we calibrate this, we calibrate only the 2 points, right? We calibrate the boiling point and the freezing point. We don't, there is no guarantee that other points actually, that is, if when we measure, if something is calibrated from between 0 and 100 degrees Celsius, if we get a measurement of 50 degrees Celsius, we cannot actually guarantee that it is truly that is truly 50 degrees Celsius, unless it is linear, specifically linear. We will not be able to say that it is 50 degrees specifically. They will definitely agree at the boiling point and the melting point, but the other points are just random measurements that we can get a rough idea of, because if they don't agree if they are not linear, if the expansion is not linear, then it is not going to be an accurate reading. Please do question number 5 and 6. We will discuss the questions at the end of the lesson. We have learned that electrical resistance changes with temperature. For metals, resistance will increase with temperature at a certain steady rate. So for metals, the resistance increases with temperature. So higher the temperature, higher would be the resistance. However, for a thermistor, the resistance changes rapidly over a relatively narrow range of temperatures. A small change in temperature results in a large change in resistance, right? So a thermometer based on a thermistor will be sensitive over that range of temperatures. So a thermistor can be used to measure the temperature of a certain period of or a certain temperature accurately, far more accurately than anything else, but only a very limited range. A thermocouple is another electrical device which can be used as the sensor of a thermometer. So this is used, you have learned this in O levels. Two different metals are used, and a certain length of one metal is soldered to the other to another metal. So they produce two junctions, and these two junctions are going to be very important. When the two junctions are exposed to different temperatures, a voltage difference is created. This voltage difference can be measured using a voltmeter, and when the temperature difference is high, higher EMF is produced, right? So, but a shortcoming is, a problem of this is that the voltmeter, the voltage that is produced might not be linear with against the temperature change, right? So that is a big problem or a shortcoming of this thing, the thermocouple thermometer. If you draw EMF against temperature, it is not going to be a straight line. That is because it is not linear. The electrical thermometers, thermocouple thermometers, can be used to measure great ranges from 0 Kelvin to even thousands of Kelvin, right? So these are quite important stuff. And here you have the basic principle of a thermocouple thermometer. There are two junctions. One is exposed to the heat, the other one is not. When there is a difference between the voltages at the 2 points, then at these 2 points there is a voltage difference that results in an EMF, and a current would start to flow. When that is measured, we can figure out how the temperature is going to be. So now here we are going to we are going to compare the resistance thermometer against thermocouple thermometer. Robustness, that is how strong it is going to be. It is very robust, and the thermocouple thermometer is robust. Range is, in a thermistor, it has only a narrow range, and a resistance wire has a wide range. And thermocouple thermometer, just remember these as names. You don't have to actually explain the definition behind the resistance wire. Then the size is going to be larger than thermocouple, has greater thermal capacity, therefore slower acting. So to get a fixed reading, you have to expose this to the source for a longer period of time. Then thermocouple thermometer, they are smaller than the resistance thermometers, and a smaller thermal capacity is needed, therefore quick measurements can be taken. Sensitivity in a thermistor thermometer, like we discussed, it can be used to measure the temperature of a narrow range with a high accuracy. So because it has a high sensitivity over narrow resistance or a narrow range. Resistance wires are going to be less sensitive. Then thermocouple thermometers will depend on what kind of metals are used. If the correct and appropriate metals are chosen, then they can be sensitive. Linearity, over that specific narrow range, they can actually be fairly linear. Resistance wires would have a good linearity. In thermocouple thermometers, it is not going to be it is not going to be linear. It has to be calibrated. The specific points need to be calibrated, but the in-between points are not going to be accurate. Then remote operation. Long conducting wires allow the operator to be at a distance from the thermometer. That is, the sensor can be placed elsewhere, and the person who is going to check that can be somewhere else. In both of these things, both of them, you can actually do that. Long conducting wires can be used, so the person doesn't need to be close to the source. Please do question number 7 as well. Let's write a note on this. Write down. Thermometers are devices that can be used to measure the temperature or the amount of heat, within brackets thermal energy, contained. Different characteristics of different materials are used and there are changes when exposed to temperatures or heat are compared when making the measurement. Example number 1, expansion of liquid in glass thermometer. Number 2, the resistance of an electrical resistor or thermistor. Number 3, the EMF voltage produced by the thermocouple. Color of an electrically heated wire. Next one, the volume of a fixed mass of gas at constant pressure. Leave a line, put a star and write down. If the change in characteristic is not linear, the scales need to be calibrated. But the values in between might not be precise. Leave a line and write. Thermistor thermometers change their resistance rapidly over a relatively narrow range of temperatures. Leave a line and write. A thermocouple thermometer compares the EMF between two junctions when one junction is exposed to a different temperature. Two junctions are made by soldering two metals end to end with a voltmeter in between. However, thermometers do not have their EMF changing linearly. As a result, they have to be calibrated properly to get a proper reading. They have to be calibrated properly to get a proper reading. Please draw this figure 19.13 and also write down the table 19.2 and do question number 6 and 7 after the 5, 6 and 7. After the end of the lesson, we will discuss these questions. If you have any further questions, please raise them.